Bicep is designed to simplify infrastructure as code workflows by offering a more concise syntax than Azure Resource Manager, ARM, templates. Modifying an existing Bicep file involves updating definitions, parameters, or deployment details in order to adapt the infrastructure to new requirements. This process typically occurs when scaling environments, optimizing resource configurations, or aligning infrastructure with organizational standards. Due to its declarative nature, Bicep focuses on defining the desired state rather than describing step-by-step scripts. Understanding how parameters, variables, and resource blocks are structured is crucial. By carefully evaluating current resource settings, administrators can plan changes without disrupting existing environments or introducing hidden pitfalls. A typical Bicep file is divided into distinct sections that guide the resource provisioning process. At the top, optional metadata and descriptions may appear to clarify purpose. Following that, parameters constitute the adjustable inputs for resource configuration, while variables encapsulate calculated or reusable values. Resource blocks define the Azure services to be deployed, such as virtual machines, storage accounts, or virtual networks, referencing both parameters and variables. Output blocks can provide meaningful information, like endpoints or connection strings, upon deployment completion. Recognizing how these sections interrelate is essential for efficient modifications, especially when multiple dependencies and complex resource hierarchies are involved. Parameters serve as externally supplied inputs or placeholders for values that change between deployments. They enable flexible use of the same Bicep file in different environments or contexts. When modifying an existing file, parameter updates might include altering default values, adding new items for expanded resource configurations, or removing unneeded parameters. A carefully crafted parameter design helps decouple environment-specific details from the infrastructure definition. Best practices include specifying descriptive parameter names, defining constraints like allowed values, and applying secure parameter types for sensitive information. This approach reduces configuration mistakes and ensures the Bicep file scales seamlessly for evolving operational demands. Variables consolidate repeated expressions or derive values for clarity and maintainability. They can be updated to reflect new resource names, strings, or numeric results derived from provided parameters. For instance, when modifying virtual machine naming, administrators can adjust the corresponding variable to adhere to new naming conventions. In more complex deployments, variables might also handle calculations, such as deriving subnet sizes or combining multiple parameter values. By refining variable definitions, changes become simpler to track and implement across the Bicep file. This eliminates the need to update numerous resource blocks manually and ensures consistency throughout different sections of the infrastructure. Resource blocks are at the core of Bicep files, describing Azure services like compute, networking, and storage. Changes to existing resources might involve switching VM sizes, adjusting SKU tiers, or enabling additional features. When updating these blocks, it is important to ensure that parameter references and variables remain valid, thereby avoiding potential deployment conflicts. If dependencies exist among resources, for instance, between a virtual network and a subnet, modifications must maintain logical order. Below is a brief example. Bicep resource myVM, Microsoft, compute/virtual machines at 2021-03-01 equal name. VM name location, location properties, hardware profile, VM size modules allow you to structure your Bicep configuration into logical units, promoting reusability and clarity. When an existing file references modules, modifications could entail adding parameters to handle new features, rearranging resource definitions, or updating outputs for improved cross-module communication. Administrators can also incorporate versioning strategies to ensure consistent module updates across multiple Bicep files. This approach is particularly beneficial in large-scale deployments, where separate teams manage components like networking, storage, and identity. By expanding module functionality, you maintain a clean architecture and enables smoother collaboration across different environments, as each module remains focused on a specific resource grouping or service area. Conditional deployments allow certain resources to be created only under specified circumstances. For instance, an organization might need an additional storage account if a high availability parameter is set to true. Bicep supports conditions as part of resource definitions, referencing parameters for decision-making. When adjusting conditions, it is important to clearly articulate the triggers and the intended resource behavior. Overly complex expressions can be mitigated by employing variables that break down logic into smaller parts. By refining condition blocks, the resulting template remains flexible and adaptable, enabling efficient deployment processes aligned with specific operational or compliance requirements. Iterations in Bicep enable automatic provisioning of multiple resource instances based on a list of inputs or a numeric count. Common examples include spinning up multiple virtual machines or storage accounts in different regions. When modifying these loops, administrators might add or remove items in a parameter array, adjust iteration strategy, or refine resource naming logic to avoid conflicts. As an example, Bicep Resource VMS Microsoft Compute/Virtual Machines at 2021-03-01 equals for I in range 0, VM count name, myVM iProperties, hardware profile, VM size. VM size from careful management of iteration variables and dependencies ensures consistent deployments at scale. When implementing changes in a Bicep file, it is prudent to evaluate their impact on existing deployments. Parameters that drastically alter resource structure may lead to deletion or recreation of certain components, potentially causing downtime. Using the what-if feature in Azure CLI or PowerShell can help visualize the consequences of proposed changes before actual deployment. Additionally, partial deployments involving targeted resource updates can reduce disruption. Logging and monitoring scripts can be integrated into existing pipelines, providing real-time insights into the state of your resources. By considering these factors, organizations maintain stability and adherence to best practices throughout the update cycle. After modifying a Bicep file, validation and thorough testing are essential to ensure accurate deployment. The Bicep build command can detect syntactical issues, while tools like Azure CLI facilitate template deployment in a test environment. Automated pipelines provide an efficient mechanism to catch regressions or misconfigurations. Use representative test values for parameters, simulate various scenarios, and observe resource states via Azure Portal or command line tools to confirm correct behavior. In complex infrastructures, employing integration tests or ephemeral environments can mitigate risks. Clear testing procedures help validate that the revised Bicep file meets the desired outcomes across different environments without unintended impacts.